Hello everyone, welcome to my channel Simplified Organic. Learn organic in simple and easy way. Today's my topic is acidity, lecture 2. Lecture 1 I have already uploaded long back. I'll add the link in the description. You can also view that video of acidity lecture 1. So let's begin with the topic acidity. Today I'm going to discuss acidity only from the NCERT book. So before that is small description, that is acidity is directly proportional to the electronegativity or also the percentage S character or also due to the stability of conjugate base. This relation is very much important to understand today's topic. So as the percentage S character increases, electronegativity increases, acidity also increases. And one more relation I have already mentioned in my last video, that is acidity is directly proportional to the stability of the conjugate base. So let's begin with the topic. So this is the NCERT book, page number 394 from the class 11th part 2. Class 11 and part 2. Okay. So in this first acidity is mentioned in alkynes chapter, in physical properties of alkyne. Sorry, in chemical properties of alkyne, it is clearly mentioned acidic character of alkynes. So first of all, why alkynes acidity is given here is when you compare alkane, alkene and alkyne, the hydrogen of alkyne, the hydrogen which is bonded to this sp carbon is acidic in nature. The reason is because it is sp hybridization, hybridized carbon. It has 50% S character, which is more electronegative in nature. So just now I told you, as the electronegativity increases, acidity also increases. So if I ask you what is the order of acidity, see here it is sp2 hybridization, here it is sp3 hybridization. So in sp hybridization, there is more percentage of S character, therefore this is more acidic in nature. So we can say an alkyne can be acidic in nature due to the hybridization character. This is what explained here in this paragraph. See, what is it saying? They react with ethyne to form sodium acetylide with the liberation of hydrogen, dihydrogen gas. These reactions have not been observed in case of ethene and ethane. So this is important. This acidity property we have not seen in case of ethene and ethane, thus indicating that ethane is acidic in nature when compared to ethene and ethyne. Why is it so? All because of the hybridization concept just now, which I have explained you, right? So next, now look at here what he is explaining. In case of ethyne, it is attached to the sp carbon, the hydrogen is attached to sp carbon, whereas in case of alkene it is sp2 and in case of alkane it is sp3. Due to the maximum percentage of S character, that is 50% S character, electronegativity increases. See here, highest electronegativity. And therefore, this bond becomes weak, easy to break. So it acts on acidic in nature. See what is he saying here? Hence the hydrogen here of ethyne bonded to triply bonded carbon is acidic in nature. Hydrogen bonded to triply bonded carbon is acidic. It means he's talking about these carbons. These are acidic in nature. But not all the hydrogens in alkynes. See, this is important. Not all the hydrogens. Only that hydrogen which is bonded to sp carbon is acidic in nature. Now the point is, how do you prove that it is acidic in nature? That can be done by two reactions, that is reaction with sodium. From your lower classes, you might have studied that an acid will react with metal to give hydrogen gas. So when alkyne acetylene is reacted with sodium, hydrogen gas is released, which proves that it is acidic in nature, forming monosodium ethanide as the product. Monosodium ethanide. When this monosodium ethanide is again reacted with sodium, see here, this monosodium ethanide, when reacted with sodium, again, you will get disodium ethanide. Again, half mole of hydrogen gas is released. So this evolution of hydrogen gas proves that an alkyne is acidic in nature. In the same way, propine also have acidic hydrogen, can react with sodium or sodamide. Gives ammonia gas the pungent smell. Ammonia gas, very bad smell, pungent smell, which proves that there is an acidic hydrogen. So if I follow this concept and apply this on, he is asking the question here, what about the above reaction with butanine, and butane? So if I apply the same concept on butanine, I'm writing here. So in butanine, there is one acidic hydrogen. So definitely it will react with sodium to release sodium gas. Sorry, hydrogen gas. To release hydrogen gas. But butane will not react with sodium to release hydrogen gas because there is no acidic hydrogen in this. So with the help of this reaction, I can easily identify the terminal alkynes. I can easily differentiate the terminal alkynes and this is internal alkyne. This is internal alkyne, means alkyne somewhere inside. And this is terminal alkyne at the corner. Terminal alkyne means at the corner. I can easily differentiate them by this reaction, that is sodium metal, or I can also use sodamide to differentiate them. Terminal alkynes will give hydrogen gas, but internal alkynes will not give hydrogen gas. This is a very important reaction to differentiate these two. So with this, I can explain here that why alkynes are acidic in nature, all because of the hybridization sp. And what about the order of acidity? Just now I have told you that order of acidity I have explained you. That is, alkynes are more acidic than alkene and then alkanes. So now look at the second order, what he gave here. Acetylene is more acidic than propine, than butane. So as simple logic here, that methyl group is a plus I group. You also have an idea that acidity is directly proportional to minus I upon plus I. As the plus I increases, acidity decreases, inversely proportional. So methyl group, one methyl group here and two methyl groups here, acidity decreases. And moreover, there is no acidic hydrogen here. In this last example, in the last structure, there is no acidic hydrogen. So therefore, this is the order of acidity. So that is about the acidic nature of alkynes. Everything is there in the NCERT. We need to go through it point by point. Now, the acidic character is also explained in the chapter alcohols, phenols, ethers. I'll tell you the page number first. So this is the page number 335. Alcohols, phenols, ethers chapter. NCRT 12th part 2. So when you go through this topic, acidity in alcohols, phenols, ethers. Now in alcohols, the hydrogen is bonded to electronegative oxygen. Here, acidity of the phenol is given. Alcohols and phenols. Now in alcohols, the hydrogen is bonded to electronegative element, oxygen. So there is a partial polarity already. Del positive. This hydrogen can come out as a proton. It can act as acidic. It can act as an acid. How can you prove that alcohols and phenols are acidic in nature? This also can be done by reacting them with sodium, potassium, or aluminum. They release hydrogen gas. Look at the reaction here. Alcohol is reacting with sodium to release hydrogen gas. This also proves that alcohols are acidic in nature. Not only with sodium, with aluminum also we can do. Aluminum more electropositive element. Active metals. See here, there is statement given active metals, electropositive metals. To give release hydrogen gas also. Here also. So these two reactions proves that alcohols are acidic in nature. Now when alcohols are acidic, then why not phenols? Yes, phenols are also acidic in nature. Phenols are also acidic in nature. See, when phenol is reacting with sodium, it again releases hydrogen gas, also acidic in nature. So both alcohols and phenols react with the sodium to release hydrogen gas. In addition to this, see, he is mentioning here, in addition to this, not only sodium, phenols also react with sodium hydroxide to form sodium phenoxide. This is the reaction. Phenol reacting with sodium hydroxide to form sodium phenoxide. Means I can say phenol is soluble in sodium hydroxide. I can say it is soluble in sodium hydroxide. He clearly mentioned that it's in addition. In addition means alcohols will not show this reaction. Alcohols are not strong enough to react with sodium hydroxide strong base. They will not react with. But phenols can react with sodium hydroxide. Phenols are soluble in sodium hydroxide. So I can use this reaction to differentiate alcohols and phenols. Again, I'm repeating, I can use this reaction. So everything is given in the NCRT. You just need to follow it properly. So phenol can react with sodium. Phenol can react with sodium hydroxide, as the phenols are more acidic than alcohol. As the phenols are more acidic than alcohols, they will react with sodium hydroxide also. Now look at this acidity of alcohols separately. He is discussing acidity of alcohols. As I told you in my previous lecture, that acidity is directly proportional to directly proportional to minus I upon plus I. As the plus I increases, acidity decreases. Look at here, this alkyl group is a plus I. Here you have two alkyl groups. Here you have three alkyl groups. So as the plus I increases, acidity decreases. See, primary is more acidic than secondary and then tertiary. So he is mentioning here, acidic strength of alcohol decreases with electron releasing group. As the electron releasing group increases, acidity decreases. This is what given here. Primary, secondary, and tertiary. This is about the acidity of alcohols. So when I move further, acidity of phenols is discussing. Now acidity of phenols. When the phenol reacts, phenol can react with sodium, can react with aluminum, and also can react with sodium hydroxide, indicating the acidic nature. But the point here is why phenols are more acidic. Why phenols are more acidic than normal alcohols? I can explain you this in different by different reasons. First one, In phenol, the alcohol is bonded to sp2 carbon. In phenol, the carbon is bonded to sp2. Sorry, the alcohol is bonded to sp2 carbon. Percentage S character increases. Electronegativity increases. So acidity increases. So therefore, the first reason can be it is as it is bonded to sp2 carbon. In case of normal aliphatic alcohols, it is bonded to sp3. So this is the first reason I can say. The second reason why phenols are more acidic. Why phenols are more acidic? As I told you, the conjugate base. The conjugate base of phenol is phenoxide. Is highly stable due to the resonating structures. 5 resonating structures. Because of 5 resonating, the conjugate base is stable. Because of 5 resonating structures, the conjugate base is stable. Therefore, acidity increases. This is the second reason. So now, just go through this paragraph, what he gave. See here, he is explaining that it is bonded to sp2 hybridized carbon of benzene, which act as a electron withdrawing group, Not only this, not only is this, see what he's saying, when phenol reacts with the sodium hydroxide, it forms phenoxide. The phenoxide is highly stable due to the 5 resonating structures. I'll show you here. Now the stability of the alkoxide and phenoxide. In alkoxide, the negative charge is localized on oxygen, means it is not moving anywhere. It is at one place in alkoxide. But in case of phenoxide, the charge is delocalized. Delocalized means it is in the resonance, having 5 resonating structures, which makes it more stable. Therefore, phenol is more acidic in nature than alcohols. See here, the phenoxide ion is more stable and favors the ionization of phenol. These are the 5 resonating structures of phenol. So these two factors, that is first one, it is bonded to sp2 carbon, and the second one, as the conjugate base is highly stable due to the 5 resonating structures. The negative charge is delocalized, so highly stable. Now let us talk about this table, very important table, that is pKa values. As I told you, acidity is directly proportional to Ka upon pKa. See, the greater the pKa value, weaker is the acid, inversely proportional. Now look at these pKa values and then you can decide the acidity order, the phenol, paranitro, metanitro, orthonitro. Now look at these values. If I want to compare these 4, according to these values, we can say that paranitrophenol is more acidic than orthonitrophenol, then metanitrophenol, then comes phenol. This is the order. They are more acidic than phenol because nitro group is strong, -I, -M group. So they are more acidic compared to that of phenol. They have less pKa values. And now compare this phenol with cresol. What do you mean by cresol? Methyl. Methyl substituted phenol is called as cresol. It can be ortho, meta, para. When you compare ortho, meta, para, methyl is a plus I group. Decreases the acidity. Methyl is a plus I group. Decreases the acidity. Means pKa value should increase. Inversely proportional, right? So when you compare with phenol, they have more pKa values, means they are less acidic compared to that of phenol. Now look at the pKa values and you can write the order. Phenol is more acidic, right? Then comes metacresol, then comes ortho equal to para. Nitro group is a electron withdrawing group, minus I group increases the acidity, and methyl is the plus I group, electron releasing group decreases the acidity. So you can mark this phenyl group as a benchmark. Here it increases because of nitro, here it decreases because of the methyl. Now compare ethanol. As I told you, phenol is more acidic than aliphatic alcohols. Now look at the values, pKa values, 10 and 15.9, means equal to 16 if you take. So now look at this, what the statement is telling. According to the above data, we can say phenol is 1 million times more acidic than 1 million times more acidic than ethanol. Look at the pK values and you can decide. Very important. So that is about the acidity in case of alcohols and phenols. So that's all for today. In the next lecture, I'm going to discuss about the acidity in case of carboxylic acid from the NCRT. What is he explaining? And if time permits, I'll also explain about the basicity of amines from the NCRT. So a lot of knowledge and a lot of information is present in the NCRT. You need to follow point to point. So that's all for today. If you want to learn about acidity of phenol and carboxylic acid comparison, you can go through my previous video. The link I will be adding in my description box. So thank you very much. Bye bye.